Oh, and to recall your memory, what you have learned last lesson is about some theory of the reaction. The first concept is about what EA is, and EA is the minimum amount of energy for a reaction to start is a first thing. And then you may ask, if you refer to the enthalpy level diagram or the energy profile, what is the use of the EA? And there are totally two functions why EA or the activation energy is needed for a reaction to occur. The first one is that if you look into this example, HCl, if I want it to form from the corresponding elements, then some H bond and Cl bond have to be broken first. And this is the first thing why EA is needed. Oh, and then the second reason why EA is needed is because for all the reactants, they are surrounded by some electron cloud and they are negatively charged. So that if you want to reactant, they come closer to each other, you must need energy for them to do so. 你要啲嘢靠近啊嘛，第一要插幫之外咧，就話你啲負嘅 electron cloud 同埋另外一嚿 reactant 上面嘅負嘅嘢咧，你要佢靠近到先至 react 得㗎嘛，係嘛？你要啲負同負嘅嘢黐埋咧，你要 energy 令到佢 overcome 個 repulsion 先至做得啦嚇。Oh, and this is all about activation energy. And there is another theory to explain under what scenario a reaction can occur called collision theory. And if you see the name of it called collision theory, then the first criteria for a reaction to occur is obviously the reactant, they collide with each other. And what's more should be that they should collide with a correct orientation. 咁啊要撞得啱位先至得啦，係嘛？咁啊特別係例如你嗰啲嘅C double bond 嘅 species 咁樣計啦。萬一你另外一嚿 reactant 咧，去撞去其他啲 single bond CH 啊嗰啲位，其實佢 react 唔到㗎。And it must collide with a correct orientation that another reactant, let's say the Br2 collide onto the CC double bond, then there will be addition reaction. Otherwise, nothing occur. So that the second criteria is having a correct orientation. And the third thing is that you should have enough Ke for that particular molecule. Is because for Ke, it can be one of the sources of the activation energy. As long as a particle, it has a Ke larger than the activation energy of that reaction, it is able to react. And by combining with another two factors that they have correct orientation with collision, then that kind of collision, we call it effective collision. 一定要係滿足晒三個條件咧，先至叫做一個有效嘅撞擊啦，即係佢先至有機會可以 react 得到啦。Oh, and next is that we try to use the collision theory to explain how some of the factors affect the rate of reaction. And the first two, for the pressure increased by decreasing volume or the concentration increases, it actually makes the particles, they come closer to each other. 我將呢兩個 factor 我上升嘅時候，其實令到啲粒子佢其實近咗噶嘛，係嘛？喺個 environment 入邊 ，so that it has they have a larger chance for them to react, and then the rate of reaction increases. Oh, and then for temperature, and what is the meaning of temperature is that it is the measurement of the average kinetic energy of the particle in the system. So if you increase the temperature of a system, then you are increasing the average kinetic energy because the particle, they move faster. So they have a larger chance of collision. And what's more is that a higher proportion of particle will have enough kinetic energy for them to react. And we will explain more in the elective part. And there is something called Maxwell-Boltzmann distribution. And it shows you the distribution of the energy possessed by our particles. So we will have a detailed discussion later. Oh, and then about the catalyst, it can help lowering. It can help providing another pathway for the reaction to occur. It's because it forms partial bonding with the reactant. It means that the bonding inside the reactant is somehow weakened. 佢將一啲 reactant 中間嘅 bonding 咧就會令到佢廢啲啦，係嘛？變咗兩嚿 reactant 佢再 react 嘅時候，其實要少啲 energy， 要少啲嘅 activation energy 已經 occur 到啦。And finally, it's about surface area. The higher the surface area, then the higher the rate. Oh, and then the next thing we talked about last lesson is about the change in rate diagram. If we change, let's say, the surface area, temperature, and the addition of catalyst. And in both of these three scenarios, you can see that the rate of reaction, the initial rate, it become higher, so that the curve it become higher in slope. 你見到佢全部都令到個 rate 會快咗啦嘛，結論就係話條線斜咗啦。However, for these three factors, it won't affect the final yield product. It's because the number of mole, the mole ratio of the reactants did not change, so that they will all go to the same level of the amount of product. 咁所以全部都斜咗，咁但係到最後咧，佢哋平嗰個位其實一模一樣嘅，係咪？個 amount of product form 其實一模一樣啦。So if you want to think of the change of the rate diagram, the change of the curve, you have to consider two things. The first thing is the rate changed by that condition change. 佢究竟個 rate 有冇改變到啦？例如佢高咗嘅條線就斜咗啦，佢個 rate 廢咗嘅，咁條線就冇咁斜啦。呢樣就第一樣你要考慮嘅嘢嚟啦。And the second thing is that is the amount of the product change. And for surface area, pressure change, temperature change, and the addition of catalyst or removal of catalyst, the final yield product, it wouldn't change. And the tricky part is about the final factor, the change in the volume of solution and the concentration of a species. Maybe I use the first as an example to show you, and hopefully you have finished all of these eggs at home. And later I will give a task to you. Oh, in this case, is the reaction between magnesium metal and then with hydrochloric acid. So initially you have to do two things, is that you have to calculate the number of moles of each of these species and to determine which of them is the limiting or the reagent in excess. And obviously for Mg, its number of moles would be 0.1 mole. And if you remember the reaction, they will react to form MgCl2 and H2. And for the HCl, I can calculate its number of mole by using Mv, so it should be 0.4. I mean 0.24 mole. Oh, and then in this case, which of the Mg or HCl is limiting? Oh, Mg is limiting. Someone suggested in the chat box already.咁就搞掂咗一開始嗰個嘅 scenario 係咩樣啦嚇。And after you did this analysis, then we can move on to the change of the curve of the new condition. So for the first case, if you consider the initial rate by comparing the concentration of the HCl, and then you can find out that in the new scenario, the concentration is higher, so that the initial rate of the reaction, it will also be higher. 咁我哋諗咗就係話佢嗰個嘅一開始嗰個嘅斜率係啲咩先啊？而家咧 HCl 佢濃咗啦嘛，咁所以佢應該個 rate 會高咗啦。So is how does the new curve look like at the beginning with a higher slope. Oh, and then the other thing we have to consider is the final amount of product. Will it increase, decrease, or remain unchanged? So again, we have to make use of the mole calculation this time. Calculate again the HCl, the number of moles, and it should be this number, 0.36 mole. Under this new scenario, which of Mg or HCl is limiting? Okay, again Mg 記唔記到啊？你嚟嚟去去都係0.1 mol Mg 啫係嘛？你一毫都係淨係需要0.2 mol 嘅 HCl 啦。So that under this new scenario, also Mg is the limiting reagent, and because this amount does not change, so it remains at 0.1 mole. So in both of the scenario, before and after, 0.1 mole of hydrogen gas is formed. And you see the idea behind. So although the initial rate is higher, However, you will go to the same level finally。我哋計毛計佢出嚟嘅係嘛？嚟嚟去去都係 mg 係 limiting 啫嘛，個 amount 咁梗係唔變㗎。So up to this point, can you follow? Only two things you have to consider for drawing the new diagram. First one is the initial rate of reaction, and you have to look at the concentration. And the other thing is by use of mole calculation to see if the product hydrogen, it will increase in amount, decrease in amount, or it will remain unchanged. And you can find the evidence by finding out the limiting or reagent in excess, and that's all. So if okay, then just try the rest of the 7 examples. And by the way, you can open OneNote 就係 set a task for you。如果你有筆嘅話啦，你可以一陣間直接喺呢度畫啦。你做咗先啦，3、4分鐘啦，應該夠嘅。之後就揾人畫啦喺度。Originally, as you may predict, only 0.1 mole of H2 is formed. However, under this new scenario, there will only be 0.09 mole of H2 gas formed. 咁所以你計完之後咧，今次應該係點樣樣？咁咪少咗0.01 mole 咁多啦嚇。So the answer should be 2。咁啊，應該第二嗰個啦，應該 drop 咗6格啦，係嘛？你數翻格仔嘅話，佢原本咧 occupy 緊60格噶嘛，係嘛？你而家係原本嘅9/10啊嘛，咁咪 drop 咗6格啦。如果喺呢個 scale 入邊，係嘛？So that the possibility 2 is the correct one. So here is how the new curve look like. Oh, and then the third scenario. 係咪啊？第二嗰個、第三咯喎。咁又係諗嗰幾樣嘢啫係嘛？究竟一開始佢斜咗冇咁斜，定係一模一樣啦係嘛？And you can just look for the concentration. And both at the beginning and then in this scenario is a 4M solution. So initially, the slope should be the same. 先 OK， 一開始佢應該一模一樣啦，係嘛？However, for the product， 同埋咧佢唔會無啦啦越嚟越斜嘅喎。咁當然啦，有冇呢啲情況出現咧？有佢自己本身係一個 self 嘅 catalyst 嘅話咧，就會有呢啲情況啦。即係佢出嚟個 product 佢本身可以 catalyze 成個 reaction 就會係啦。However, in this case, it is not a self catalyst, so that the curve can only be increased with a decreasing rate. So the next thing is about the new product, new amount of hydrogen gas formed. What's the new number? 0.08, thank you. If you do the calculation, then HCl, the number of moles will be 0.16, is it? And then because the mole ratio of hydrogen is only a half of it, so the 0.08 mole of hydrogen is formed. And of course, the volume is only 80% of the original one. Okay, so it will, in this scale, it will drop by 12. I think you can handle the final one, is it? 最後嗰個啦嚇，一開始應該係同樣嘅 slope lah, because the concentration they are the same. However, in this case, for hydrogen, it has 0.32 mole, and only 0.2 mole of it is littered. So there is again the reagent in excess for HCl, and Mg is the limiting reagent. So the amount of hydrogen it should remain unchanged. Oh, and then just try to analyze it one by one. For the initial slope first, maybe I do all of these together. Originally is 4m, so that for the second scenario, it should be increased. 所以第二幅一開始嗰個位啱啦，係嘛？ Oh, and then for the third one, initially it should have the same slope with the original one because both of them are 4m. And then also for the final one, initially it should have the same slope. 咁所以 tick 好嗰幾廿條線就啱啦嚇。Oh, and then the second thing you have to analyze is what is the final output level. And if you do the mole calculation for the second scenario for HCl, it should become 0.48 mole. And in that case, originally it is the limiting reagent. However, in the new scenario, it will become in excess because only 0.4 of it is littered. So that the new limiting reagent, it will become Mg. And then 0.2 moles of hydrogen, it will be formed. So for the pink curve drawn by one of your classmates, is correct. The final output level it will increase. 咁我升咗幾多？應該就升咗0.8咁多啦嚇。唔係 ，I mean 0.08咁多啦。Oh, and then third one, I think two of the classmates also get it correct. Is because the new number of moles of HCl is 0.16 mole. And because originally HCl is limiting, and then its concentration is even lower in the new condition, so that it is still limiting. So that all the hydrogen formed will be governed by the number of HCl, and it is only 2/3, so that the curve is also 2/3 of the original amount. Is it okay? 咁佢嗰個 number of moles 係原本2/3啦，係嘛？自然畫出嚟 hydrogen 都係原本2/3啦。Oh, and then for the final curve, HCl it will become 0.8 mole. And then in this case, the final product level will be just equal to the one in the second scenario. It's because Mg now become the reagent in limit